Hey, so a reminder, we're getting the computer to learn to play Doom, and specifically ViZDoom, and we're specifically the defense center scenario. Now, in the previous episode, we implemented entropy regularization, which should help the computer to explore the world, not just fire ahead of it all the time, which is what we did it in the first run. In this video, we're going to launch a new run, and we're going to follow that run as training takes place. So let's get started. Alright, so then I'm going to go up to the instance. I'm going to stop the current run. We are going to change it. So run to, and we have to give the scenario name. Alright, so that's running. Let's try plotting the graph to check that works. So AWS pull, and then let's do the graph. So this is going to be run 2. So this is plotting reward, which is going down, and then we want to plot the entropy, whatever it's called. So right, argmax action prop here. Alright, so this is the argmax action prop. Going through the batches, it's around about like 0.3 to start with. And I guess if we pull again, it might have started to increase. But anyway, we can clearly graph it. There we go, so it's increasing. Alright, so we're going to let that run for a while and see what happens. So we're going to look at the reward. So later on, we're going to look at the reward. We can try playing the game, running the game, and seeing what happens. And we can get this graph showing the percentage of time when we are sampling. The sampled action equals the argmax action. Alright, so it turns out I didn't leave, and I just started looking at more results. Alright, so it went right up to the proportion of time went right up to 0.9, and then it's falling. If it falls too drastically, then our entropy regularization might be a bit too high. But we'll see. The other thing we might want to mess with is, so the reward currently is always positive, I believe. I mean, we can look and see, right? The reward is basically always positive. And when the network's learning, it needs to sometimes get positive and sometimes get negative. If it always gets negative or always get positive, it doesn't really learn very well, because the weights always get pushed kind of in the same direction in a sense. So we might want to subtract some number from the reward so that sometimes the reward is negative. There's a couple of ways of doing that. One is just to guess some number to subtract from it. So sometimes it's negative and sometimes it's positive. Another way is to have a baseline that tracks the average reward. But the problem with that is it gives instabilities. So we might mess around with the first way to start with. I'm tempted to increase how often the model saves so that we can look at this more often. So let's save every 100 episodes or something. What episode are we on now? Batch 33. So batch 33 is 528. So what is 32? So maybe let's save every 512 episodes. So let's push that up. And we're just going to restart that. And I'm just overwriting the model and the log that we just created. Cool. Alright, so let's leave that to run. We'll look at this probably in my morning, but in about 10 hours of elapsed time. Of course, I'm not sure how this is going to be split across different videos. We'll see. Anyway, see you in the next clip. Hey, alright, so now it's 11 o'clock on Saturday night. So it's, I guess it's like an hour or two after I started the instance. So let's take a look and see what's happening. So we can SSH in here and we can do a pull here. So we're still getting a reward of around 1. The argmax proportion is fairly confident, but it's not like 1, it's just like 0.9. Let's have a look at the graph. So this is the argmax action proportion. So it's become a lot more confident, but it's not like 1. If it was 1, I'd be worried, but like 0.9, 0.95, that's fine. And let's have a look at the reward. Oops, that's not how you spell reward. Huh. So it sort of went up and then it's gone down again. That's weird. And the loss. I need to understand the loss a bit more actually, because I'm not sure why it's... The loss is going down. Why would the loss go down if the reward is going down? We should log the length of each episode too. Let's try playing an episode and then do run 2. Well, it's turning now. It's turning and firing. It's turning a lot. It's not bad actually. Like, it needs to learn to fire when the monster's in front of it. I think so. It's missing a lot of monsters, but its strategy seems pretty good. Like, it's a lot better than before, right? Like, it's not just like standing in one place and firing. It's turning, and it is hitting a lot of monsters. It could hit more, but it's doing pretty well. I'm pretty happy with where it's going. I mean, it's not going anywhere, it's standing in the center turning, but the direction that the learning is going seems good to me. It's good. And this is after like a couple of hours? Like, what episode are we on? So we're on batch 400, which is like episode 6000. And in the previous scenario, it took 40,000 episodes to learn, and we're only on episode 6000. So I think it's doing pretty well. I'm happy with what's happening. So check in again, probably tomorrow morning my time, like Sunday morning. So anyway, see you in the next clip. Hey, so it's 7 o'clock on Sunday morning, and let's check how the learning is going. So I'm going to SSH into my instance on the one hand, and I'm going to pull the logs from the instance on the other. Alright, so we've pulled down the latest model and we've pulled down the latest log file. And on the instance, so the reward is around 1.8. Our entropy regularization might be a bit high because we want this to be around about, we want the proportion of times it chooses the argmax to be about 0.9, and it's only about 0.5. So we might want to reduce our entropy regularization. Anyway, let's look at the graphs. And we'll also see how the model is playing. So this is the reward. So I haven't looked at this yet, I'm just running it now. Alright, so it went up and then it went down, and that's gone up again. It's up to about 2. Alright, and then let's look at the proportion of time it's choosing the argmax. This one, right? Y-axis, argmax action prop. Alright, so Okay, so in the bit where the reward was bad, I guess we can plot both graphs somehow. Alright, so we're going to copy this into ViZDoom images, and then we're going to call it, so defend the center, run to, and then argmax prop. Alright, and we can open that. Alright, and let's do the other graph, and we're going to put that into ViZDoom image, defend, center, run to, and then this is the reward.png. We could actually make it do all of them. Alright, so here's the reward, and here is the argmax prop, and you can see when it was super confident and always basically choosing the argmax all the time, the reward is lower, and then when it became less confident, the reward is higher. Right, let's see how this is playing. So run model, scenario defend center, yeah, this should work. So we pulled down the latest model from the instance, and let's see what's happening. So it's still turning, but it's shooting a whole bunch of monsters when it's turning. It would be neat if, perhaps we should give it the ammo count. Do you know why? Because, you know what we need to do? We need to do two things. Thing number one, right at the moment, the game ends after 200 steps. Why does it end after 200 steps? So if we look in the script, we are setting an option to end the game after 200, because if we look at the top, we've got set episode timeout 200. I think we should remove that. And that way, the agent has to conserve ammunition, which means it shouldn't just continuously shoot. Because at the moment, the agent only has enough ammunition. The agent has plenty enough ammunition to last for 200 steps, I guess. If we set this timeout, like remove this timeout, then the agent will run out of ammunition. So I think the first thing we should do is remove this timeout. I'd also like to modify the normalization. So the reward is kind of going from 0 to 3. So the reward should be balanced. It should be about as positive it is negative. Like you want the average reward to be 0, so that sometimes there's a positive gradient and sometimes the gradient goes the other way. Just like if you've got a supervised learning problem, you want as many positive examples as negative examples. Otherwise, it doesn't learn very well and stuff. I mean, if you only had positive examples in supervised learning, it wouldn't learn. Alright, so here it's kind of similar. We want to have the reward about as positive as it is negative. On average, we want the reward to be 0. And here on average, I would say that the reward is 2. So why don't we just simply subtract 2 from the reward before we calculate the loss and back prop. Alright, so that's the end for this training run. In the next video, we will look at making the code changes we talked about just now, which is changing the episode timeout and changing the reward normalization. So hopefully I will see you in that video. If you don't want to look at the code changes, you can just skip to the video after that. Alright, see you either in the next video or the video after that. Hopefully.